All right, welcome. I think we have a pretty good turnout today. Last I heard, we had 52, 54 that had signed up for this, so I know your time is valuable. I appreciate you guys taking a little time out of your busy schedule to spend some time with us and to learn more about the engineering management program here at CU. Today, we're going to talk, I'm going to give a little bit of an intro about the program, and then I will be handing it off to Professor Bailey, who will dazzle you with her brilliance on quality. So with that, let's jump right into this. Let me preface this by saying I'm going to go through these slides fairly quickly. Don't fret. We will provide slides for you after the fact, so that if you're jotting down notes, don't feel too bad if you don't get it down in enough time. All right, so the agenda, I think I already covered this. I'm going to start with about 10 minutes of talking about the program and really kind of elaborate on, I'm also a student or a former student, and so what I got out of the program and why I decided that I wanted to come and teach here. So with that being said, again, I'm a product of the system. I think now I believe we have 4 faculty that have gone through and got their degrees through the program that they are now teaching in. I think that kind of bodes well for, it's a good testament to the program. And I can say that if the program can turn me into this, it's doing a pretty good job. I can tell you that as a student, I maybe struggle a little bit with not only presenting, but I never thought I would be in a leadership role and actually teaching. So I feel like this program, really changed who I am. And I think it has that power to do that exactly for you as well. And so what do I teach? For the most part, I teach leadership. I do teach a little bit of the management side of it as well, but my passion is leadership. In my free time, I like to do endurance athletics, Ironman and ultra marathons. And I've kind of taken what I'm learning from that world and the things that I've learned as far as mental toughness goes and grit and resilience, and try to bring that into the classroom so that I can teach business leaders how to be more mentally tough. So I find that as kind of a fun little, you call it a little bit of field research. So with that being said, my undergrad degree is in mechanical engineering from CU Denver. And then again, my master's degree is right here from Boulder in the engineering management program. So I'm a buff, I bleed black and gold, you would say. So I'm definitely a big fan of not only the program, but also the university. For a lot of you, you've already probably, you have a foundation of leadership, or not leadership, but engineering. And I pulled this stat out, which I think you might find interesting, that 1/3 of all S&P 500 CEOs have a degree in engineering. So you're well positioned to, if you desire, to kind of step up and maybe climb that ladder and aspire to something greater. Let me also say that when I took the program, or when I went through the program, I did not have a strong desire to move into leadership and or management. And a lot of my students, including myself, by the time you graduate, a lot of times that changes. And I think that's a wonderful thing. If we can, turn more people, more individual contributors into leaders and managers, that's a good thing. Some more quotes that I pulled up out of the research, kind of focus on the fact that, this first one here, you can see that, make sure I'm not getting out of the camera here. We live in a global world. We teach our students to kind of exist in that world and to embrace that. So I think that's a big part of what we do here. The next one is talking about an engineer is hired for his or her technical skill, fired for poor people skills, and promoted for leadership and management skills. So I think that's important to know that your technical skills are nice, but it's almost like that's not enough anymore. And to really advance in your career, you need to add a little bit more to that. And that's what we do here at the engineering management program. And then lastly, maybe I'm a little biased, but this last quote, I'd like to see more engineers stepping into leadership roles. I think with the engineering background that we have, we are well suited to step into that and be very successful. So what is engineering management? I like to think of it as essentially a gear chain, and that gear chain, as you can see from this graphic, is that we are tying together the worlds of business and engineering. Again, I want to emphasize the fact that even if you don't go into management, to be able to speak the language of business and to understand maybe what your manager is dealing with and understand that and maybe have a little empathy for what they're going through will make you a better engineer. So I guess my message to you is don't discount the program if you don't have those aspirations just yet. One of the big differentiators for our program is, and I hear this from my students all the time, they love the fact that all of our faculty are people that have been out there in, the real world. We have industry experience. We can bring those war stories into the classroom, so to speak, and the students really get a lot of value out of that. And so I think that, that's probably a little different than most of the programs here at the university. We're not doing research. We're here to teach you. We are a teaching organization, and I think you get a lot of value from that. So one of the big questions that we get is, why would I take this degree over an MBA? Sometimes an MBA is the right choice. I'll be completely honest with you. You can see from this graphic, you will get through it a little bit faster. We have fewer requirements to get through the Masters of Engineering. And I would say that if you're going to be in a technical field or engineering, these classes are very relevant to what you're going to do. One of the things that I loved about the program was every time I took a class, I was working full time and I could take that right into my job the next day. Not a lot of classes are like that. So it's very specific to what you might be doing in a technical field. And the MBA is going to be a little bit broader. I would say that if you're going to go into maybe other areas of business, maybe the MBA is the right choice. Why might it be the right path for you? You can see from this graphic, again, the obvious choice is you want to advance in your career. But again, some of it is just wanting to learn and grow and improve. So I think it'll make you a better engineer if you go through this program. So think of our program as essentially three ways you can, I would say, consume it. And we have students that follow each one of these three paths. Obviously, the big one is getting the Masters of Engineering Management. That's the big chunk. But you can also do smaller things like getting a graduate certificate or maybe even getting a dual degree. Let's take a look at those a little closer. This is on our website. I'll also tell you it's not all inclusive. We basically have 5 core courses. That is an inclusive list. But the electives, we also have 5 electives. And there's more to our electives than what you're seeing there. That's just a sampling. You'll see more of that on the website. I think this is nice, and again, this is something I hear from our students, that you get a lot of latitude to have the flexibility to take the kind of courses you want to take and the ones that might be the most relevant to you. I can tell you when I finished my degree, there was 5 or 6 more classes that I wanted to take. I think we have a great suite of classes that seem to interest almost everybody that comes into our program. The graduate certificate would be, it depends on the certificate, but most of them are 3 to 4 courses. And so if you decide that maybe the master's degree is a little more than you want to bite off right now, you can go a little shorter path to get the graduate certificate. Although I'll warn you that a lot of times people end up starting with the graduate certificate and then move on to get the master's. So they enjoy our courses so much. Here's the dual degree program. If you have questions about that, please reach out to Kendra to explain how that might work, but you can get dual degrees through our program as well. So Does it meet your needs? One of the big selling points and differentiators for our program is it's very flexible. You can come to class live, sit in class. I always think that's the best way. You can watch it on video live, and you can also watch recorded lectures. So you have essentially 3 ways to do it, so it gives you a lot of flexibility. I've had students that are in Alaska that are taking my courses. So wherever you are in the world, you can kind of tune into the course and take it that way and consume it. I've already talked about the course content. You get a nice balance with the required and elective classes. And then again, the faculty all have industry experience. It's a quote from one of our students. This is just a small sampling of where our graduates end up. Anywhere from SpaceX to Medtronic, some of the military institutions, you name it, across the board, we have graduates out there. Just a little bit of marketing here to show, this idea of leadership, learning that business language and increasing your self-awareness. So is it for you? One of the things that we live in a competitive world, you're going to have to go out there and compete with other people for jobs. And how do you differentiate yourself? And this is a good way to do it. How are you going to put yourself on the top of that resume stack, I guess I would say. And this is, I would say, a wonderful way to do that. With that being said, what I loved about this program was my instructors. I feel very fortunate that I get to not only that I went through the program, but also that I get to call these folks my colleagues now. And this is just not me. I hear it from our students all the time of how much they love our faculty and how much interest they take in individual students. With that being said, I'm going to introduce you to our next speaker, the rock star of quality. She's going to dazzle you with quality and statistics. And if anybody can do it, it would be Professor Bailey.
Thank you. Well, I want to say welcome to everyone who showed up today, and I also want to say welcome to those of you who couldn't come today right now at this time, but you're watching this later because you're interested in what engineering management is about. We're going to look at a specific area of engineering management, which is quality management, but also I like to call it quality science, because we're not just talking about skills that we're building, and of course many of you probably have management skills and leadership skills already, which can be further developed in our program, but we're looking at the science that's behind making improvements in business. So thank you so much, Professor Duren, for your introduction, talking about the engineering management program. I would second his comments, and because I also went through this program. Now, I did my career a little bit different. Here's what I did. I started out as an engineer at Anheuser-Busch. I jumped right into it, and I became really good at what I did. I was great at statistics. And so a lot of times when you're really good in a technical area, you get promoted. So I was 24 years old. This was 24 years ago. And they said, we're going to make you a manager. And I said, that's great. I'm so excited. And I had no idea what I was doing. Absolutely no idea what I was doing. Now, of course, did I learn along the way? Did I have great mentors? Absolutely. Had a great experience, learned so much. When I came back to school here at CU Boulder, everything that I learned was applicable to back then. If I had the knowledge, and trust me, I was very successful in my career, but if I had that knowledge and learned all of the things that I learned when I went through this program after I had completed that part of my career being an engineering manager, there would have been no stopping me. Absolutely. And really, it wasn't just about me. I would have grown, I grew lots personally during this program, but I could have done so much more. And so I want to encourage you today to take a look at what we have to offer, because I can tell you from personal experience, and Professor Duren can tell you as well, the things you learn here are precious and actually probably won't be learned anywhere else. And you have so much flexibility. It's fantastic. So with that, let me give you a little bit about my background. My undergraduate education was also mechanical engineering at Purdue. Yes, I'm a boiler, but I'm also a buff. I got my master's in engineering management. I specialized in the area of applied statistics and got my master black belt in Six Sigma. Now, I also had my master black belt when I was practicing in industry. However, I just said, I'm going to get this again. And I'll tell you, I learned far above and beyond anything I could have learned in a training course. I can't even begin to tell you the difference. It was kind of like just sailing on the surface versus doing a deep sea dive. And so with that, I learned a ton here, and so I humbly call myself a quality ninja at this point because I have 2 master black belts, but I want to see you become a quality ninja. And that's what you can get from our program. So I mentioned that I worked for a company called Anheuser-Busch. I worked for them for a couple years first as a process engineer and then was promoted into management. I held several different positions there and combinations of positions, including engineering manager and quality manager. And it was a great time, and I worked for that company for 14 years. I also, after that, I took a break, had a child, got back into education, and I worked in technical education at the community college. When I completed my degree here, an opening came up in the area of my expertise. I was so excited, just jumped right on board. So we're going to talk a little bit today about quality and what quality is. But first, I want to ask you a question. And that question is this: what is the purpose of business? Of course, this is a rhetorical question. You may answer it. And some of you, if you were here, you would say things like, it's to make money, or it's to provide a product. But I want to propose to you that really business has a lot of purpose, but the main purpose of this is to make the lives of people better. We can all do things individually, but when we come together as a group in the context of a business, think about all the ways that you can make improvement, not just in quality, but in all areas. And there's all sorts of people involved. You have customers in a business. You have employees in a business, owners, suppliers, and the general community. All of those things, what a great opportunity there is to make improvement in the lives of people. And that's really what I believe the purpose of business is. And quality plays a big part in that. Because when quality isn't working, none of the other stuff is working either. It's not a happy place. So the main concerns of business, in addition to providing a great opportunity to improve the lives of people, successful businesses are going to enhance several things. First, they'll enhance value, perhaps of the product or the service that is being provided. We're going to hopefully increase and grow revenue for the company, increase the market share if that's what our goal is, our strategy is for our business, growing and becoming more profitable, which really is the bottom line. How do we improve the lives of people if our businesses aren't profitable? And imperatives in any business include things such as cost, productivity, and quality. All of those things are required. In fact, it requires in this day and age more than just the basics. It requires every ounce of intelligence that you have available in your company and business. So why do we want to focus on something like quality? You've probably heard of quality, and maybe you have some context for a background. You think of people who are inspecting things, checking things. Some people feel like the quality folks are the police of the organization. But what quality does for your business is help reduce things like rework and waste and extra testing, and it helps increase your overall volume and yields for productivity, especially if you're in a business that you're creating some type of product. It reduces costs for the organization. It increases customer satisfaction, which will help increase your market share. And then finally, it helps increase overall profitability. And that profitability is not just so higher ups can spend it on themselves. It's so that we can reinvest back into the business, back into the people who are in the business, and make that business better. All right, so let's talk about what the definition of quality is. And quality can be viewed from several perspectives. Of course, there's kind of this transcendent or judgmental perspective, which would say, hey, what is quality? And you might say, not really sure what it is, but I know it when I see it. Okay, now, of course, your perception of what quality is can be influenced by, I don't know, things like marketing. All right, I might say, ooh, a Tesla, that has great quality. But then when I look at the data on returns and warranty costs and all of those types of things, that might tell a little bit different story. But if I look at it and it has a brand and I think, wow, that's really going to be high quality. But what is the test of quality? Sometimes we think if it's expensive or a brand name. Or if you look at features, here's the Homer Simpson car. If you ever watched The Simpsons, you remember Homer created his own car and it had all sorts of bells and whistles on it. Of course, he was booed out of the organization. But lots of different features. Looking at a product perspective, there could be quantities of product attributes. When you think about buying a new car, there's different types of features in your car that might be a selling point. For example, air-conditioned seats. That might be a selling point. Something that might not be a selling point would be, I don't know, automatic seat belts. I would call that a negative feature. So more features, some folks feel like more features equals better. Now, this fellow right here, his name was Joseph Juran, and he was a fellow who worked in Japan after World War II to help turn around the organizations over there. And what he said from the user perspective is, does it work? Okay, is it fit for use? And specifically, is it fit for the intended use? How well it performs that intended function is another way to look at it. Now, of course, we can look at the value perspective as well, the quality versus the price, and of course, a customer or consumer is going to make their purchase decision based on perceived quality versus the price given. But there's also the manufacturing perspective, and I want to focus on that a little bit here. Now, a lot of folks, you've probably heard of specifications for a product characteristic and what that should be. Let's say we're looking at a hole and we say, oops, let me grab this back here. Let's say we're looking at making a hole in a board. Oh, that's not lined up. Okay, forget the pen. We're not going to do that. Okay, we're looking at a hole in a board and we're saying it needs to be 1 inch in diameter. Of course, there's a specification. It could be plus perhaps 1/1000th of an inch and minus 1/1000th of an inch. And folks say anywhere in between there is going to be good. I want to show you today that that is a myth. It should be conformance to target, and we call that target. In quality, we call it nominal. And nominal is a word that we use that expresses that the target that is given is an ideal target and it's been obtained through research as opposed to just grabbed out of thin air. So let's take a look at these quality myths and principles. There's a few of these. Achieving quality doesn't happen by accident. It happens with a lot of purpose and a lot of planning and a lot of science that goes behind that. So that begs the question, why is it so difficult to achieve? Well, there's a lot of myths out there and some principles that are missed that I would like to talk about today. And we're going to cover 4 myths about quality and 3 different principles of quality. So let's look at the first myth of quality. And that is as follows. Here we have some specification limits. The LSL, that stands for lower specification limit. The USL stands for upper specification limit. Now, I'd probably have some type of target in between here. And I'll just use my pen to show you where it would be because it doesn't want to write for me. But perhaps that's 1.5, and I would say something like this. This is the myth. Anything inside the specification limits is good. Anything outside the specification limits is bad. So this is what I call kind of the goalpost theory. If I can kick the football between the goalposts, I'm good. Doesn't matter where it goes. So here's the question I have for you. Let's say I make a part right here, and it is 0.9999 inches. And then I make another part here, and it is 1.0001 inches. What is the real difference between those two parts? And someone says, oh, I know, it's 2/1000 of an inch. Okay, that's true. That's the difference. But perhaps there's more to it. Let's say I do multiple samples. I sample again and again. I get one in and out, in and out, in and out. I'm going to begin to build a distribution over here. Of course, it's drawing it over here. But imagine a normal distribution, a bell curve over here, where I actually have 50% of what I'm making out of specification. But I don't know it because I'm just looking at one sample, taking that sample, and then making a decision on one sample. So we put our organizations at a lot of risk with this methodology, and I would say this is kind of the mindset between 1950 and 1970. Unfortunately, it's still alive today. So I want to show you how this could potentially cause problems in an industry. The myth number 2 is related to myth number 1, and that is that all parts falling within specification are equal in quality, cost to purchase, manufacture, or cost to use as part of a greater product. So there is something called a cost of quality. It can be measured. It's measured with an equation, and actually a quadratic equation for those of you who are mathematically oriented. It's called the Taguchi loss function. We're going to look at that. So quality is conformance to specification is the myth. Let's talk about an example here. Now, many of you have televisions, and I'll give you an example, and this one actually is from the 70s, but still pertinent today. So color density was something you would have on your television set. And of course, the TVs back then weren't like the TVs today. You actually had to use a picture tube, and that would be in your TV. If you've ever seen those big TVs and they're really fat on the back end of it, it's not a flat screen. Those have the big picture tubes in them. Well, the color density gives how dense the color is, how it looks on the screen, whether it looks fuzzy or clear. It can also affect the color. So Sony was making some TVs, and they had 2 locations supplying these picture tubes. One of the critical characteristics associated with this color density, or this picture tube, was called color density. And Sony in San Diego, they were making some picture tubes, and this was the distribution of color density for the picture tubes they were making. You can imagine they were making millions of these things. This is what we would call a uniform distribution. And notice that they take up the entire range of the specification range. And we have Sony Tokyo also making picture tubes. And you'll notice that they had about 3 out of 1,000 that were out of specification based on this distribution. But notice where they were centered with the distribution. The majority of what they had was centered in the center of that specification area, closer to target as opposed to using up the whole specification range. And what they found was that there were warranty issues. Customers were turning televisions, this was very expensive for them, with picture tubes that were made in Sony San Diego. Now, there's no way that the customer would know where the picture tubes were made, but Sony knew. And so they really had a different perspective on how to manage quality, where the manufacturing facility in San Diego was saying, we'll just use up the whole specification range, where the folks in Tokyo were saying, we're going to try to conform to target. And the results were very, very different. And so this comes to play with a fellow named Genichi Taguchi, who developed something called the Taguchi loss function. And basically, the Taguchi loss function says the following. He says that as a product characteristic deviates from its design target, its nominal or ideal target, he said the loss to society increases. Now, of course, in the United States, much of the time we say that the loss to the business increases, or that there's a cost to quality, it increases. But he really took it so seriously. He said, you know what? This was after World War II. He said, we'll never be able to turn around business in Japan if we don't pay attention to these types of details and use science related to quality, as opposed to just saying, yeah, anything in here will work. So the loss function looks something like this. We can take that same specification, the lower spec and the upper spec, and put a dollar loss. So as the process deviates, as color density was deviating from the appropriate target, a loss occurred. And you can see this is a quadratic function. It increases the further that you get away from that target or nominal value. So you can see where there were more costs associated with the color density or the color picture tubes that were being made in Sony San Diego versus the picture tubes being made in Tokyo. So the goal here, and this is your first principle associated with quality, is to reduce variability around that appropriate target. So the reduction of variation, if you left with nothing else about quality today, I want to tell you this. Quality is all about reducing variability. It's all about reducing variability, and that's the goal of the quality effort. That's what we teach here at the in the engineering management program in the quality science. And we don't just tell you, we show you how to do it. Okay, so it lowers your total cost. It's going to increase your productivity, and that results in a reduction of loss to the organization. So in business, we have all sorts of variation. We have uncertainty, we have risk. We want to reduce that uncertainty and that risk, and focusing on this principle is one way to do that. Now, those were two quality myths. Let me show you another one. If you just conform to target, and I would say just manufacture just a conformance, okay, we would call this plus or minus 3 sigma. You may have heard of 6 sigma before. That would be very different than this. This would be a tighter, much tighter distribution around the target. But if I'm just making the minimum, being minimally capable, I'm going to show you. You'll see what happens to this distribution when you introduce the effects of long-term variation and looking at quality as measured through time. Shift happens. So your process can shift. And in fact, the methodology behind 6 sigma even takes into consideration that a process can shift plus or minus 1.5 sigma. So 6 sigma is not really even 6 sigma, it's 4.5 sigma. I'm not going to talk about that today, but you have some quality trivia for you. So the second principle is that the goal of this effort is to conform to the nominal or target and not just to the specification limits. Because we know the process is going to shift, and we know that as we conform to the appropriate target and minimize variation around that, we reduce loss to the organization. So the goal here with the Taguchi loss function is to eventually get to a product characteristic or service characteristic, whatever that characteristic may be, process characteristic, doesn't matter. We want to reduce variation around the right target. Now, the other part of that is we don't want to have any defects. So we are going to do an exercise here to prove, I wouldn't say prove, but to verify one of my next points here. So the quality myth number 4 is that you can make things that are defective or out of specification, and it's not going to, you're not going to ship it to your customers. So we're going to see how great visual inspection is. How effective is 100% inspection? And I'm going to give you a test here. It's going to take about 1.5 minutes. I'm going to have you inspect a paragraph. And the letter F is a defect. This includes both the upper F and the lowercase f. All of this stuff, this accoutrement on the side here, that doesn't count. Okay, just the paragraph. All right, so I'm going to have you do this. We'll see how good you are in inspecting. I'm giving you 1.5 minutes. It'll be an awkward silence for 1.5 minutes. On your mark, get set, go. And if you get through it, you can go ahead and count another time and another time. Once you get an answer, type it in, and I'm going to have our folks monitoring your questions tell me what number you got. 20 more seconds. Okay, time. What number did you get? Any numbers?
38, 36, 42,
38,
37,
36, 42. What else?
44, 43, 31.
Wow. Okay, 40. Okay, we've got all sorts of numbers. Why aren't you all getting the same number? Well, here's the answer, in case you wanted to know. The answer is 48. Okay, yes, they're saying that they got 47 over there in the audience, which is good, but is it 100% effective? And the answer to that is no. And were they to do this later at night, they might get a different answer if I mixed up and gave them a different paragraph. So the thing about inspection and 100% inspection, and especially visual inspection, when it comes to the human eye, is that it's about 85% effective. And that's on the average. It could be lower than that. It could be higher than that, but it's not likely going to be much better than that. So we think that we could sort out all the bad ones ourselves, but if we are knowingly making something defective and we ship something, it's likely that there are defectives in what we are shipping and sending out. So the principle, and this is the last quality principle I want to share with you today, is that the only proven method for shipping product 100% within specification 100% of the time is to produce it perfect the first time. Okay, so we can't do it without that. Now, where a lot of companies start, and perhaps this is your company or your experience, is with something called the product control cycle, where you have some inputs to a process, you make something, and you have an output. And you're going to sample that product and measure that product. Now, if the product's okay, I'm going to compare it to spec, and if it's in spec, I say it's okay to ship. But we saw with the first quality myth, that could get us in trouble really fast. Now, if we're just making 2 or 3 things a day, it's not in specification, no big deal. But when we're making 5 million of them a day, it's a huge deal. It's a huge deal. Okay, I remember one of my colleagues was working at Ford, and he saw someone measuring some parts. He had a box of parts in front of him. He had a micrometer, was measuring them. So my friend walked up and he said, "What are you doing?" He said, "Oh, I'm measuring these parts. And if they're in spec, I put them in this box on the right. But if they're out of spec, I put them on this box on the left." And he said, "Okay, well, what do you do then?" He goes, "Well, what I do is I remeasure the parts in the box on the left that were out of spec, and if they were in spec the second time, I put them back in the in spec box." And he said, "Well, do you remeasure the ones that are in the in spec box?" He goes, "Oh, no, I already know that those are in spec." So you can see where we trick ourselves into thinking something's okay. Something could be in spec or out of spec, but we have to consider there's measurement error and all sorts of things. So it's really not a powerful way to control our process. Same with this product control cycle. Once I make it, it's done. I've got all of the materials and the labor, everything spent on making that product. If it's not right, I have to throw it away or rework it, and that becomes extra expensive to do. What we want to do initially is start moving our testing a little bit up further stream. So where I'm not just looking at the output, but I'm understanding the relationship about things that are happening in the process. We do this through using statistics and doing industrial research. We measure things that are happening in the process. We analyze them and make adjustments to the process before the output even comes out. So we're controlling it a little bit further upstream. And then ideally, we understand the relationships between inputs and outputs, and we're not just adjusting the process, although we might, but we understand how the inputs are going to be processed, and we make adjustments at the inputs too, before we even get to this point here. I liken it to this situation. Many of you probably like to do things out in the outdoors, and if you don't, that's okay, I don't either. But let's say you're camping and you find a beautiful location. It's amongst the trees in Colorado, and you're camping. There's this beautiful fire you have going, and you go to get some water. And you notice that there's just like a little off taste in the water. Now, a disclaimer, don't ever do this. I know you're super smart, you're engineers, business people, you would never do this. Don't drink the water, ever. Always assume that there's a beaver upstream. So you could taste this water and be like, ooh, there's an off note. And then you're like, you know what? I'm going to do a full factorial, fully crossed model and do an analysis of variance and find the best place to sample the water that's going to have the least amount of off flavor for the water that I'm drinking. And that would be one approach, and it would be potentially effective, but minimally effective. What you want to do is move that whole process upstream and then sample in front of the beaver. Find out how you can get the beaver to go away and never come back. That's what we're doing with the quality effort, is getting rid of things that aren't supposed to be there and make sure they go away, and then optimizing the things that should be there and make sure they stay that same way the whole time. So that is a manufacturing perspective, and one that we do focus on in our program here. And of course, there's the customer perspective. When we focus on the things that are important with the process, it becomes a lot easier to meet or exceed customer expectations. So when it comes to the definition of quality, this is what it is. This is what I want you to walk away with. It's the continual or ongoing reduction of variation around a customer-defined nominal. Remember, that word nominal means the ideal target in the absence of defects. That's what it is. That's what it comes down to. And that's what the Stats Division of the American Society for Quality defines quality as. Now, you can segment quality into two different aspects, both of which we focus on in this program. One is conformance quality. So we looked at conforming to a specification, conforming to a target, right? And this really, conformance quality has to do with how well the product is manufactured or the service is provided consistently achieves design requirements. So I liken it to a hamburger. Now, many of you may not like hamburgers, or you may not like this restaurant, but one place that does it very consistently is McDonald's. Now, you may think, okay, well, they do it consistently bad, but it's consistent. So if I went to McDonald's in Boulder versus McDonald's in Fort Collins or McDonald's in London, I pretty much know what to expect when I order a quarter pounder with cheese. It's going to be the same, and that's something that they focus on, is conformance quality. But when it comes to design quality, I may have a different idea of what design quality is. I may have some expectations as a customer that would have to be met with some other design that's out there as far as cheeseburger quality. Maybe Lark Burger, or the one where they put butter on the burger. Culver's, they just straight out there like, let's just do the cholesterol thing and put butter on the burger. Fantastic, sign me up. That's high quality to me. All right. So design quality has to do with how well the product or service specification meets the needs and expectations of the customer. And of course, that's very important, because you could make the highest quality typewriter. I doubt you're going to have a lot of people in the market searching for the latest design in typewriters. So again, to summarize everything, quality doesn't happen by accident. It happens with purpose. And how do we implement these principles? How we implement these is through quality management. And quality management has to do with three things. It has to do with systems, it has to do with strategies, and then the tools, all three of which we teach in the engineering management program, and specifically in the quality sciences. So the system in management is the way in which an organization is going to manage its business processes, but strategies are techniques we use within that system. They're organized steps, and they're designed to address a type of issue. A strategy could be making improvement in customer satisfaction. Another strategy might be the steps we take to eliminate a defect or a failure. And another strategy might be, and is, how do we reduce variation in an existing process, or start up a new process with minimal variation? So those are the strategies. There's lots of tools that we use in there. Could be analysis of variance. It could be linear regression. It could be statistical process control or process capability. And we teach you lots and lots of tools within strategies, within a management system, within the engineering management program. So why do we want to do this? Because in addition to leading and managing, engineering managers are also involved with processes. So you have the voice of a customer, you have the voice of a business, but you also have a voice of a process. And so to be a strong technical leader, you have to be able to speak that voice of the process, and the processes that you're dealing with don't tell you things unless you generate data. They don't say, hi, I'm having a bad day, I'm not working. What you're planning to do is not going to work. However, when you use data and industrial research, your process will tell you exactly what it thinks. So engineering managers will do things such as designing products, they'll design processes, they'll design services, make decisions and solve problems, and analyze data. So all of these things come into play when we're talking about quality science, and all of these things directly affect quality of the product or service. So the courses that we offer here at the University of Colorado in Boulder include courses in the quality science and also courses in research methods. And specifically, is this more aimed at industrial or business type of research. And so the classes that we teach in quality science include topics in value creation, methods for quality improvement, and advanced topics in quality systems and engineering. And then that's married with research methods. At the bare minimum, you would want to take the Intro to Applied Statistical Methods, which is a great applied approach to making decisions using data. And then further, you can get into more advanced type of industrial research with research methods for experimental design, advanced statistical methods for engineering research, and then finally, data mining and screening experiments for engineering research, one of my personal favorites. Also with our program, we do offer certification in Six Sigma. If you want to get Green Belt, which is your first level, you would take Introduction to Applied Statistics, Methods for Quality Improvement, Advanced Topics in Quality Systems, and Research Methods and Experimental Design. If you want to move up to the Black Belt level, you add a couple more classes. And if you want to be a master, just to explain, Green Belt's 2 projects, Black Belts oversee Green Belt projects, Master Black Belts oversee Black Belts. That's how the hierarchy works as far as belt certification. So we would add things, advanced topics in value creation, and also Professor Duren's class, leading oneself. Because we can't lead others in an organization until we can first reflect upon what we're doing and lead ourselves. So that concludes my part of the presentation. What we're going to do now is take questions from you about our program, anything that you want to know about. Professor Duren and I are going to sit over here, and we are going to talk about whatever is important to you.
All right. So can I work in high tech post graduation?
Professor Duren, your mic is not
Nope.
on.
Thank you.
Can you work, you want to take that one?
Sorry, I got a little, could you say it again?
Can I work in high tech post graduation?
Of course you can. I'm going to make the assumption that that question's coming from you're not working in high tech now. Maybe I'm making a bad assumption, but yeah, obviously this degree will set you up well for working in high tech.
So I work full time. How many hours, or how many hours per week outside of class is typical?
Okay, so let's talk about how many hours inside of class. I did this degree myself, working full time, and I would recommend, if at all possible, take no more than 2 classes while working full time. Depending on what class you take, There are different requirements as far as outside of class work, and you can find that information actually online. There's something called a faculty course questionnaire, and it'll give, one of the questions asked is how much time do you spend outside of class working on class material. Of course, certainly if you're going to take any courses in the quality sciences or research methods, I'm happy to advise you on what classes you would want to take together versus which ones you might not want to take together too. Some are a little bit more intense than others. I would say at minimum, it would be 4 to 6 hours outside of the classroom, and at maximum, I would say 13 to 15.
And can I add to that? I went through the program and I took one class per semester. A little bit of a longer route, but a lot of times you'll find that your employer will pay for it if you're working full time. And so that was what worked well for me. To give you an idea, that took me, I think it was approximately 5 years to do it that way. So that's another option. So adding to what Professor Bailey said.
All right. So Wendy, are there any topics in quality management systems such as ISO, such as 17025 or 22?
Okay.
I don't know what those mean, sorry.
I can't remember what one, I'm guessing that's the medical device industry, but I don't remember off the top of my head. I want to say that it is, but yes, we do talk about ISO. We don't spend a lot of time talking about how to get ISO certified, and it's not an ISO certification course. Certainly there's courses you can take through ASQ that would help you get certified in that. We do talk about some of it. More of it, what we talk about are the systems that you would have to have in place in order to get ISO certified. And any type of ISO certification, ISO's changed throughout the years with respect to quality and quality management. What they really want to do is see that you have systems in place that really reduce risk, and they want to see evidence that the systems you've put in place actually make improvement over time. So you have to have that evidence, and unless you were actively employing, it's not just paperwork. That's what it used to be back in the 90s. I had a bunch of paper, I'm ISO certified, but I don't have the results to back it up. So what we teach you here is how to get the results that would back up your ISO certification.
Do you need an undergraduate degree in engineering to participate in this program?
The answer to that is no, you do not. I believe you might have to, if you don't have an undergraduate degree, you might have to take a course on the fundamentals of engineering, in addition to whatever your coursework is for the program. But no, you do not have to have a degree in engineering.
So with your backgrounds, I don't know if you could answer this, but how would this program benefit a construction manager?
You can take that one.
Yeah, my background is not construction management, but I would think that it would work well. I mean, we spent a lot of time on topics like project management that I think would fit well into construction management. Of course, some of our courses, and again, you get to kind of decide what courses are more relevant to you with electives. But I do believe you could get some good value out of this for construction management. There would be some that may not be applicable. I guess would be the best way to kind of leave that. But yes, I think you would get some value.
So what courses are more on the technical side as most are management oriented?
Well, I can answer that. Any of the quality science and research methods classes are going to involve mathematics. So those will be on the more technical side. Professor Michael Reedy also teaches some classes in product development, and there are some more technical types of approaches. And I believe Professor Gibson also has some mathematics involved in her project management course. And of course, I'm assuming that technical means using some math behind there, but I would say those are more technical as opposed to perhaps Professor Duren's course, Leading Oneself. I wouldn't say that one is more important than the other. I would have to say that the Leading Oneself course is probably, for me, was the most important course. even though I'm doing numbers all the time and using statistics a lot in my work and outside of my work, that was probably the most life-changing part for me. So all of them, you get a well-rounded education, and you can explore what you're interested in. It's there will be some technical aspects of every course.
All right. So how much value added would a master's in engineering management versus a certificate, have when I enter the job market with a master's PhD in engineering already? In your opinion, is it worth it to do a master's in engineering management at this point?
Good question.
Yeah, it's a great, I'll start, maybe Wendy can add to this, but I would say it depends on what your master's is in. The PhD, a lot of times it doesn't hold a lot of weight in industry, at least in my opinion. Is such a tough question to answer because it depends on who's the hiring manager, who's making that decision, of what is important. Of course, if I'm sitting across the table from you and I'm interviewing you, I want to see the Master's of Engineering would certainly hold more weight. But again, this is a person that already has a master's degree. I would like to know what that master's degree is in. So it might be a nice add-on. It's hard for me to say whether that would be a good thing to add another master's degree to your resume. I don't know, Professor Bailey, if you want to add anything.
I would say it really depends on what you want to do. So let's say you have let's just theoretically say you have a master's degree in mechanical engineering and a PhD in mechanical engineering. If you're applying for management positions, you might be well suited for a research position, but you wouldn't necessarily be someone to be considered for a management and leadership position. So if the engineering management degree, and it would help you to develop your skills in that area far beyond what you think you could even be developed, that would help you in the job market. So that would be an argument I would make for that. If your goal was to get into research and development, I would say that at this point, adding another degree to your resume wouldn't be advisable.
So I understand it is not a requirement to have an undergrad degree in engineering, but do you think it would be beneficial for someone with an undergrad degree in business?
I would start with what field are you going into? If you're going into an engineering field or maybe you're in one already, yeah, certainly it would be beneficial to you. If not, maybe not. I mean, I think it's as simple as that. We certainly gear our program toward the engineering and the technical side of it. So I think it would depend on where you want to end up.
All right. So there's some more admissions type questions that I can answer offline. Maybe one coming through. As a full-time engineer, if I'm considering the master's degree versus getting my PE, which should I focus on first? I'm 1 year away from being able to sit for the PE exam.
Well, I think you can do both. So if you can remember all of your spring equations from mechanical engineering, then you can take your PE, which is a possibility, of course. They throw anything at you. You have to design a system for something, I'm sure. I think you could do both. Perhaps you would just want to take one class in the engineering management program while you study for the PE. I would say studying for the PE would be a shorter term type of situation where maybe you're going to study for 7 or 8 months, and then your engineering career or engineering management program coursework, you'd be working on that consistently through the next few years. Depending on what industry you're in, the PE will bring you some more responsibility. If you're going to be inspecting homes, it's going to give you a lot more responsibility. But you don't, won't necessarily get you a better job. And if that's what you're looking for, it depends what you're motivated to do, but the skills you'll learn here will Well, many of our students get promoted, many.
All right.
Are we out of time?
I think we'll wrap up, but I'll put my email in the chat if people have
Okay.
specific
So Kendra's going to put her email in the chat in case you have more specific questions to follow up with. Kendra will answer those for you. I just want to, again, thank you for coming today, and we hope to see you here at CU Boulder next semester. Come join us. Thanks for coming.